Hi, hello. So these are your second video notes. So go ahead and title it Unit 2, Zeros of Polynomials, Alternative Methods. In today's video notes, we are going to focus on finding zeros of a polynomial function using completing the square. This part of a preview before seeing completing the square is kind of reviewing exactly what we've learned so far in Algebra 2 in terms of zeros. So we've learned how to find zeros mostly in this section up here, solving by factoring. So just to refresh your brain, we did some GCF. We did, let's see, probably grouping. What else have we done? We've done box method with the T-chart. And then maybe you can also say long division for this as well. Right. Okay, so all of the things that I wrote in green are focused on solving by factoring to find zeros. We have not focused on finding zeros by completing the square by quadratic formula, nor by applying the square root property. But in this video, we are going to focus on completing the square and applying square root property. Next week, we'll focus on quadratic formula and review this concept. Right, so just as a quick review, let's say we have a function where it says f of x is equal to x squared minus 8x minus 9, and let's just say that it says find the zeros. Okay, if it says find the zeros, we know we're going to have to set this f of x equal to 0. And then we're going to need to apply our box method to factor. And when we do that, we know we have to figure out what two numbers multiply to give us -9, but add to give us -8. And we'll find out we'll have x minus 9 and x plus 1. All right. And then we apply zero product property. And we'll get x is equal to -1 and x is equal to 9, right? And these are our zeros, right? And over here I have a visual picture. You can see the zeros are at -1 and at 9. And that piece we're familiar with. The thing is, these zeros are whole numbers or integers, okay? Okay, these zeros are integers, meaning we haven't worked with decimals or fractions, right? So today we're going to explore how to find, how do we find the exact zeros if something seems unfactorable or it appears that it doesn't look like it can be factored. So here's a good question. Make sure you write this down in your journal. If our equation is not factorable, how can we find the exact zeros? Okay, and the answer to this is completing the square. Okay, so let's take this for example. Let's say it also says here find the zeros for g of x, right? And you know, you're like, okay, I'm going to set this equal to 0. I'm going to get my two binomials. I'm going to do box method. If you do box method, you're going to realize that there's no such thing as two numbers that multiply to give you -1, but add to give you 2, right? Because the only two factors that will multiply to give you -1 are -1 and 1. But when you add them, you'll get 0. Right? It will never give you 2. So it looks like it's not factorable, and that's true. But that doesn't mean that they don't have zeros. It actually does. And right here I provided a picture of where the zeros are located. And you can see there's one here and one here, because that's where they cross the x-axis. But they don't cross exactly at the corners of the grid here. So that means they're not integers, but they are probably fractions or decimals. And that's the piece that we're going to find out today by using completing the square. So right here in your journal, I'm going to type this out. Let's see if I can type this out. Okay. In your journal, you can go ahead and write what is completing the square? So completing the square, the purpose of this is to find a value that makes quadratics, that makes the quadratic become a square trinomial. Okay. So we're going to elaborate that on this next problem right here. Okay. So go ahead and write example 1. So we have example 1, find the zeros of g of x when it equals x squared plus 2x minus 1, right? So we're going to go ahead and talk about the process of this, and I'm going to go ahead and write it. Do I want to write it that way? Yes, okay. So I'm going to go ahead and write it right here. So here's the step-by-step process. So step 1 is that we want to isolate variable terms. Okay. Step 2 is going to complete the square. And this is going to talk about creating a square trinomial. Step 3, we're going to apply square root property. And step 4, we're going to simplify and solve using inverse operations. Okay, so these are your step-by-step process. Okay, so completing the square process. All right, let's talk about, oh man, what just happened? Why did it? Okay. Perfect. So this is our process, and we are going to follow exactly how we would start with the regular factoring with the zero. So we want to set this equal to 0. So 0 equals x squared plus 2x minus 1. And then step 1 is to isolate the variable terms. So we're going to go ahead and isolate the variable terms by basically getting rid of everything that is not has a variable term to the other side. So here we're going to add plus 1 plus 1. And so we're going to have 1 is equal to x squared plus 2x. And once we have this, we're going to we can see here that the x squared plus 2x is incomplete. It's missing the constant value, right? So for step 2, it's saying complete the square, right? So we want to create a square trinomial. So we're going to figure out what number, what value will actually go right here to complete this into a perfect square trinomial. So the way we do that is with this lovely fancy formula where we have 1/2 b squared. So what this b represents, so just remembering from our quadratics, I'm going to write this maybe like one time, where we have a x squared plus b x plus c is equal to 0. Right? So recalling that the b is the number that's in the linear term or middle term, and in this case b is 2. So here we're going to do 1/2 times b. You can think of this as your scratch work, so times 2 squared. Okay, so we simplify this. 1/2 times 2 is 1, and 1 squared is 1. So this number is actually going to be the number that we're going to use to complete the square. In other words, to fill out this little bubble right here. So we're going to go ahead. I'm going to rewrite this problem, but with 1. So here we have 1 is equal to x squared plus 2x, and the new 1 that I'm going to add in there is plus 1. but recalling that whatever we do to one side, we're going to have to do it to the other side as well. So we're going to add that 1 not only to the left, but also, or not only to the right, but also to the left, plus 1. Okay, so then we'll get 2 is equal to x squared plus 2x plus 1. Okay. Once we have this, we can simplify this trinomial, and we can get 2 binomials by using box method. And when you do this, you'll notice that you'll get x plus 1 times x plus 1 is equal to 2. Okay. Now, what's really important for this piece is realizing that we have 2 binomials that are the same. If they are the same, that means we can rewrite them in this format, in the format of just writing in a single binomial, but squared. And we have x plus 1 is equal to 2. Once you have gotten this, these 2 factors into this format or structure of x plus 1 squared, that means you've completed the square, okay? So this is the example of a perfect square, or perfect square trinomial. Perfect square trinomial. Okay, so because it's a perfect square trinomial, we can apply the square root property. So right here, square root property, we can go ahead and take the square root of this. And so all that means is we're going to take the square root of both sides. Okay, so here we have, if you take the square root of something being squared with the exponent of 2, that means you're going to undo it and just rewrite what's left over as your base. While on the left side, you're going to have a positive and negative version of your answer. Okay. Once you have this step, then your last step is to simplify and solve using inverse operations. Okay, so notice that our x term is not isolated, so we need to go ahead and use our basic Algebra 1 skills and isolate the variable. Okay, so we can say that x is equal to -1 plus or minus the square root of 2. Right? Another way to write this is x is equal to negative square root 2 minus 1, and x is equal to square root 2 minus 1. Okay. Now, notice that these are not whole numbers. I'm not going to do that. They are not whole numbers. And that's exactly what you want, right? Because we notice back up here that these are not exactly touching the corners of the grid points on our graph paper. So that means that they are not exactly the whole integer values, but they do have zeros. So in this case, this is where x is equal to negative square root 2 minus 1, and this is where x is equal to square root 2 minus 1. So this process is called completing the square, and that is going to conclude our video. There is a process about how to solve with a leading coefficient greater than 1, but for this video, I just want you all to focus on when the leading coefficient is only 1. All right, so go ahead and write down your summary for this video, and I want you to write down 2 main key ideas or concepts, and then 1 question that you still have. All right, that's it. Bye.